Yes. So these type of things, mostly related to plastics are done by injection molding, mainly the bottles. And now maybe you can have that idea once I said injection molding. Okay. Anyway, so these are little, hard question, little practical question. These are not usually asked directly, but yes, when it comes to, some theoretical or, little involved question, you do good actually. So don't worry too much about it. What is creep?
Creep is a permanent deformation which is due to permanent deformation which is due to stress. The stress when it is provided for a passage of time.
Correct. And
Permanent
what?
deformation which occurs with stress
Correct.
when it is applied for a passage of time.
Correct. And what are the parameters that would essentially, increase this creep? Can you think of any parameters?
Type of loading, first of all,
Okay.
and time of loading, passage of time,
Correct.
and the material properties. Is it ductile? Is it brittle?
Right. What do you think the temperature will do?
Yes, the temperature will also have an impact on that. Temperature, if the temperature is increased, creep will also increase.
Correct. And why does that happen?
Because I think with temperature, the strength properties of the materials decreases. When we're talking about strength of materials and just confined to strength of materials, the materials which we study, ductile, and when our discussion is confined to ductile and brittle materials, in that
Mhm.
case, temperature has this effect.
Correct. Correct. That is correct. Um, so let's say you are an HPCL engineer, you are posted at a place. It is a very remote in nature. And you have to, weld two metals regularly in that remote place. You have no electricity.
Okay.
So can you think of some welding method through which you can do this? You have no electricity there. Okay. So essentially you cannot use arc welding.
Thermal welding is a process which can be
Correct. Thermite welding. Can
which
you
is
think of?
react. Okay, think of some more examples.
No, no, that's okay. How does a thermite welding work? That's a correct
It
answer.
uses a reaction of aluminium oxide and iron oxide and aluminium oxide, aluminium.
Hmm.
So it's a displacement reaction that results in iron and aluminium oxide.
Correct. And
So
it
iron will be used for welding.
correct. And where do we see this happening? I mean, can you think of any example?
Railway,
Yes, a
railway
railway
track.
track. We regularly use it in railway track. So that's a very correct answer actually. Yes. Yeah. Coming back to the question, how would you manufacture the key? See, you are already good at manufacturing. Okay. I mean, it's not that you don't know things, but yes, how would you manufacture a key?
I think by
See,
forging.
anyway, you have just four processes in manufacture so far. Okay.
So forging can be used for key
Correct.
manufacturing.
Forging can be used. That is true. Why will you use forging?
Forging because it increases the strength. It's very good for refining the strength, mechanical properties of the material, and these require good mechanical properties.
Right. What do you mean by mechanical properties here?
Hardness, uh, toughness, hardness, toughness. Yeah, hardness and toughness mainly.
Yeah, that is true. That is true. Okay, so let's say Bipasha, you have been preparing for all these competitive since so long. You join HPCL and then you get call from another organization. What would you do? I mean, should we take that chance?
Uh, no, sir. Once I get to join HPCL, I will not leave it because HPCL has been a dream company for me to join, and so I will not leave HPCL. There's no turning back after joining HPCL.
Okay, and like let's say HPCL jobs profile can vary a lot, and you have been posted in a department where you have to travel every once and now. So will that be okay for you?
Yes, sir. It will be fine.
Okay, great.
Absolutely fine.
Chalo. चलो विपाशा, तो फिर let's conclude your session. I mean,
Okay.
really good improvement since last time we met. So like for example, तुम्हारा why HPCL का आंसर मतलब थोड़ा और इम्प्रूवमेंट चाहिए था. You did that really well. So
Okay.
good. I had also asked you to revise a little bit. I think you have done that. Now you have direct clarity over the concepts, over the subjects, and like that. So really good. Also, tell me about yourself today was really straight to the point. So really well done. थोड़ा I would say जो on time thinking आती है वो थोड़ा improve करो.
Yes.
ठीक है. And
Okay.
nobody can teach you that. It's just whatever whatever you do, you just spit it out. So that way, uh, see, technical you will manage really well, no issue, because you know things already. But HR side क्या है, सब चीजें पढ़ा नहीं सकते, बता नहीं सकते, like that. Okay, so prepare that well, and that will be good actually. Yes. Chalo Bipasha, so can you please give me a small review over, how did you find the session? So, what did you like? Maybe what could we improve? And how do you feel about all these mock interviews that are being conducted?
Uh, it's very helpful. It's been very helpful. This is my third session of interviews, and I think the focusing on every detail and every problem which we have given, and you correcting us every by details, so that it was very helpful. Uh,
Definitely. Yes,
and
yes,
we look forward for more interviews and such sessions.
yes,
Thank you
definitely.
so much.
Thank you, Bipasha. So when do you have interview?
On 28th Feb.
अच्छा, शायद
Okay.
27 से स्टार्ट हो रहा है. चलो अच्छा है. Good.
Yes.
Yes. Who wa- who wants to come next? Okay. Hi Mahesh. How are you feeling?
Yes, sir, I'm feeling good.
You're good. Okay. And how was morning, today's breakfast that you had at HPCL maybe?
What? Once again, ask, sir. I didn't got.
I asked you how was your breakfast that you did at HPCL today?
It's good, sir. I didn't take in much, but it's okay because early morning I can't eat that much, but I taken it's well known.
That's all right. You look very energetic. So that's why I asked. That's really nice. Okay, Mahesh. So can you please introduce yourself?
Yes, sir. As you said, my name is M. Mahesh Babu, and I am from one of the district in Andhra Pradesh, that is Vizianagaram, and I completed my schooling and undergraduation and post graduation in Vizianagaram, that is near to the Visakhapatnam district. And I completed my undergraduation in 2020, and I completed my master's in machine learning in 2022.
Uh,
And
uh, can you please, attach earphone? Maybe you are not very clear actually. Or you already, तुम already earpiece पहन के हो क्या? हाँ, उसी वजह से
oh
शायद
yes,
नहीं
yes,
आ रहा है. Can you please try removing it maybe? ये ब्लूटूथ वाले ना थोड़े परेशानी करते हैं. Great. Uh, yes, Mahesh. So, why do you want to join HPCL?
sir. Outside people, most of the people knows earlier. Me also thinks that HPCL is well known for petroleum and refineries and their HP gas and natural gases, those things only. But later, I came to know that this is not only the refinery industry or petroleum industry. It is concentrating more the mostly on energy sector also. And nowadays, it's participating in so many pipeline constructions and different projects R&D, and it concentrating on biofuels and biofuels and renewable energy sources using also, and it is concentrating on different types of lubricants. As I am a mechanical engineer and I completed my design, my masters in design. I hope I will be fit in the R&D department and different types of designs in the pipeline construction. And I know the fluid mechanics concepts. I can apply for the lubricants design, and like that. I, like that, I thought, and that's why I want to join HPCL. This will be a good platform to get a knowledge to me. That's the reason.
That's really wonderful actually. So, Mahesh, you have your MTech in Mahesh, you have MTech in design, and let's say you are placed uh, in a department where maybe a fluid side is more used, or it is more on the little bit more on a managerial side. So how would you feel about that?
What, sir? Once again, repeat that one.
So you have a MTech degree already. You have a master's degree in a design,
Yes,
and
sir.
let's say you are given a department of maybe a fluid side, or you are put in a degree management department. So how would you feel about that?
Sir, there is no any problem because they will give the definitely they will give the option for me to sometimes they will give the option to choose among them. If I get them, then I'll okay. If I don't get, then I will do that work along with by using my skills also. If fluid side also okay, because I completed my engineering in mechanical engineering. So fluid side also, I think I don't have any problem with that one also.
That's actually great. That's amazing. So Mahesh, what are the subjects you are comfortable with?
Sir, strength of materials, fluid mechanics, and thermodynamics, sir.
That's great. Can you give me how would you state second law of thermodynamics?
The straight law is we can't get 100% efficiency by any engine, or we can't get COP as a infinity by using refrigerator or heat pump, sir. This is the in short form. If I want to tell about the laws like Kelvin Planck's law and Clausius statement, the entropy of a cycle is less than or equal to zero, and entropy of the process is also less than zero. And if Kelvin Planck, if we comes about the Kelvin Planck statement, we can't able to we are not able to design any engine which is works which gives 100% of work without rejecting any heat or any losses. That is the thing.
Okay. So can you state second law of thermodynamics in terms of entropy?
Entropy, sir.
Yes, in terms of entropy.
Entropy of a cycle is less than or equal to zero, sir. If I
Is that is that correct?
Yes, sir. If entropy is equal to zero, then it's a reversible cyclic integral of the ds by dt, sir. The dq by t. If it is equal to zero, and it is a reversible process, and if it is not equal to zero, it is a irreversible process, sir.
Yeah. What is this statement called as?
Clausius, sir.
Clausius inequality. Yes.
Yes, sir. Clausius
Yeah. So now
inequality.
can you your answer is correct. Now can you tell this in terms of second law maybe? It is related to entropy. See, dq by t is not entropy.
It is impossible to construct a device which doesn't produce any entropy generation.
I mean, see, there are hypothetically there are reversible devices which has zero entropy generation. Hypothetically,
Yes, sir.
yes, we can have. It's not impossible, but it's hypothetical.
Yes, sir. Hypothetical. In
Uh-huh.
practical engines, we can get
Yes, practically it won't be there.
will be there.
Yeah. So
So
essentially,
entropy of
yeah, essentially, second law states that entropy of a closed system or entropy of universe always remains constant or keep on increasing.
yes, sir. Constant or keep on increasing.
Yes. So that's what the second law is actually in terms of entropy.
Okay, okay, sir.
When does it?
I
When
have
does it?
to,
Yes. When does it remain constant and when can it increase?
if it's a process is isentropic process, sir. In such cases, it will be remains, sir. In in real process, it's always increases. Like adiabatic process, in adiabatic process, it may increase. If it is if adiabatic plus irreversible process, then entropy will increase. If it's a adiabatic and reversible process, then entropy will be constant. In real process, it's difficult to get a constant also.
It's correct. And what happens because of that? Can you give me some uh, things that happen because of the entropy generation?
Like because of the friction,
Mm-hmm.
because of the friction losses, it will be happen. And another thing was, if it's a process is a free expansion process, then also.
Correct. That's correct. So where do we use free expansion? You just mentioned free action, free expansion.
Free expansion process means like in throttling process we can use. In throttling process also free expansion process.
Correct. And where do we use throttling? And why do we use throttling process?
Throttling we uses in the vapor compression refrigeration systems, and where we want to reduce the temperature and pressure, there we will use throttling means creating the restriction to the passage of the fluids. If we do like that, then enthalpy will be constant and the pressure will be reduced from high pressure to low pressure. In such cases, temperature will be reduced.
Correct. So essentially, it's the temperature that we want to reduce.
Yes, sir.
And that's why we are doing it.
Yes, sir.
Sure. That's correct, actually. Can you draw vapor compression refrigeration cycle?
Yes, sir.
So this is your first interview or what? This is your first mock?
Yes,
Okay.
sir. Yes.
Okay.
Is it visible, sir?
Yes. Yes. Yes, it is visible. So what is process 1 to 2?
1 to 2 is isentropic compression, sir.
Is it isentropic compression? Yes, it is isentropic compression.
It's
Correct.
isentropic compression.
Correct. And why do we have that compression essentially? Any specific reason?
During the compression we can do using isentropic process or isothermal process, sir.
Correct.
But doing the compression by isothermal process is difficult when compared with the isentropic process, sir.
Correct.
That's why we prefer the isentropic compression instead of isothermal. But compression work will be less with the isothermal process only. But practically it's difficult. That's why we are doing isentropic.
And also, if it's isothermal, we won't be able to use the condenser actually. Condenser temperature should be higher than atmospheric temperature, right?
Yes, sir.
Correct. Why?
So, condenser temperature should be above the atmospheric temperature.
Yes. Is that correct?
The condenser temperature.
What's the condenser temperature in a refrigeration cycle that you drew right now?
Its condenser temperature is around 32 to 34 like that, sir.
Right.
Atmosphere temperature, if it is condenser temperature is more, then
What will happen is condenser temperature is lower than atmospheric temperature. Okay, in your diagram,
will be reduced.
In your diagram, which process is the condensation process in your diagram?
2 to 3 process, sir.
Correct.
If we reduce the temperature, then pressure also will be reduced, sir.
Right.
In such case, atmospheric air may, and there is a chance of leakage into the condenser, sir.
No, see, leakage chances is there always, okay, all the time. Okay, let's say at temperature 1 to 3, at your point 3.
Yes, sir.
The temperature at point 3 is low. Can you show me your diagram once, please? Okay, yes. So point 3 is in liquid line, right?
Yes, sir.
Yes. let's say if the temperature at point 3, it is above atmospheric temperature, it is below atmospheric temperature,
Yes, sir.
what will happen? Let's say atmospheric
Below,
temperature is 30 degrees Celsius and your point 3 is at 20 degrees Celsius. What will happen? Is it okay?
in
I
such
mean,
cases,
yeah, is that okay?
yes, sir, in such cases, subcooling will be happening, sir. No,
No, there is no subcooling happening. Let's imagine there is no subcooling happening.
sir, less than atmospheric temperature, we can't get, no, sir.
Why?
Okay, okay, this is refrigerant temperature, no?
Yes, this is refrigerant temperature.
Yes, sir, yes, sir, yes, sir.
So the point 1 is already very below atmospheric temperature.
Yes, sir, yes, sir. If we reduce the temperature further below, then
Okay, what does a condenser do?
condenser removes the heat from, he exchanges the heat from the refrigerant to outside water, sir.
Correct. So it is giving out heat from refrigerant to atmosphere, right?
Yes, sir.
Correct. Now, for it to give out the heat, its temperature should be less than atmosphere or more than atmosphere.
More than atmosphere, sir.
Correct. So now, can the point number 3 be at temperature less than atmospheric temperature?
Yes, sir. No, no, what, sir?
Can point number 3 be at a temperature which is less than atmospheric temperature?
No, sir, it's not possible.
Yeah, that's what I was talking about. Okay. That the temperature should be, you got confused actually about the whole refrigerant thing, about the condenser thing, but that's okay. Mahesh.
Hello,
Ha, okay, yeah.
sir.
Okay, you get the point that I was talking about?
Yes, sir. Atmospheric temperature is suppose 30 degrees and your point 3 is at 20 degrees.
There will be no
That one only,
heat.
no, sir.
What will you heat? Yeah, heat exchange will be reverse now. Then atmospheric heat will come into the system, and we don't want that.
Yes, sir. Yes, sir. Yes, sir. Yes, sir.
We want the heat
Yes,
to go out. So that's why the condenser temperature should be always higher than the
maintained
atmospheric temperature. Yes.
higher
So
than
now
that.
we want the condenser temperature to be something like maybe 40 degrees Celsius.
Yes, sir. Yes.
Yes, but evaporator is very cool. Evaporator is, let's say, as 10 degrees Celsius. So that's why. And that's why
Yes,
we
sir.
use the throttling device. Yes, you are right now. Okay, Mahesh. So let's conclude your session now. So today I touched more on the thermal side actually. Okay, because see, you already have a PG degree, so I don't think there would be any concern in your design side. But still, so what are you doing after your MTech? Mahesh bhai? हाँ Mahesh. Hello.
Hello,
हाँ Mahesh.
sir. What you said? What you
So
said, sir?
so I said that today I touch your thermal side actually, because
Okay, sir.
you already have a PG in design, so that won't be unconcerned. So what are you doing right now after your PG?
Sir, after my post graduation is completed in 2022 in the month of September. After
Right.
that, 3 4 months I prepared for the gate. I didn't got that much good. After that, I joined in TCS and
Mhm.
I worked there for 6 months. There, I didn't satisfied with my job and I did resignation. After that, again, I started preparation. Now I'm attending for these interviews.
Okay, great. And how was your gate?
This year, my gate is not that much good, sir.
Okay, fine. Okay, so Mahesh, after this is over, just DM me, okay? We'll talk as well maybe. Okay.
Okay, okay, sir.
Yeah,
Okay,
that will be great.
okay, sir.
So yes, so you have very good profile, very strong profile. So that's really nice thing to have. Then, as I said, don't tell your weaknesses. It's not a good thing to do.
Okay, sir.
Okay. Yeah. Then,
Okay, sir.
yes, you need to little reduce your tell me about yourself. As I said,
Okay, sir.
just tell your BTech, MTech, and your MTech project. That should be it. You don't need to tell your strength and weakness within itself, your introduction only. I mean, it is for those
Okay,
people who don't have much to tell in introduction, but you already have, extra degree, maybe 2 extra projects or something like that.
okay, sir.
Okay. And also, see, don't really comment about the things that you are not sure about. For example, you just said that HPCL will give me an option for department choose or something like that. Okay. Yeah.
Okay, sir.
If
Sir,
you are in,
in such case, what I have to select,
nothing
sir?
happens. Okay. सब भगवान भरोसे होता है. Overall, I would say we just
Okay,
don't know कौन कहाँ कैसे जाएगा, किस डिपार्टमेंट में
okay,
जाएगा, किस यूनिट में जाएगा. We literally don't know. ठीक है. So
sir.
everything,
Okay,
you can consider that everything is random at nature. So
okay,
always say कि if you given you are in giving interview at HPCL, say कि जो भी HPCL देगा मैं ले लेगा करके. ठीक है.
okay,
Yeah, I will use my knowledge, I will use my expertise, and everything as something technical. Say something like that. Okay.
okay, sir.
Great, great. So and see, तुम्हारा जो थर्मल साइड है वो थोड़ा ब्रश अप कर लो. रीजन बीइंग इंटरव्यूज
Okay,
में थोड़े थर्मल साइड में क्वेश्चन ज्यादा पूछे जाते हैं. Because thermal
okay,
side
sir.
question, we have 3 subjects on thermal side: thermo, heat transfer, and fluid mechanics. But on design side, we have only one primary subject. I'm talking about primary subject. Okay, strength of material.
Yes,
So usually things are more asked on thermal side. You have a PG, so no issue. That's great actually. You are a very strong profile. But point being कि थोड़ा अपना इस side बढ़ा लो. Thermal side brush up कर लो. ठीक है.
okay, okay,
चलो.
sir.
So,
Thank you.
Mahesh, this was your first interview, actually very good one. So why don't you please give me a small review actually. So Mahesh, it was your first interview, and today we touched your HR and technical side. So how do you feel about it? How do what is your review?
Sir, as you said, this is my first interview, and I hope I performed well. And I did some mistakes, and I got what the mistakes and how to give my introduction and how to brush up the things and what the areas I have to cover. All those things I learned. As I'm okay, I am happy with this mock because mock is just to test our communication skills and remaining all those things.
Yes, yes, Mahesh.
These the things that I have
Yes,
mapped.
yes, yes. So Mahesh, thank you very much. Now let's see what
Thank
we
you.
can do. Yeah, thank you. Yeah.
Okay,
So
sir.
Bipasha Reja, Ranjan Kumar. रंजन कुमार आपका हो गया है क्या?